All right. So today we're going to work on solving equations. All we're doing today is solving equations. We're going to solve exponential equations, which are equations with the variable and the exponent. We're going to solve logarithmic equations, which are equations with one or more logarithms involving a variable. You will not have a logarithm and an exponent in the same original equation. So you're not going to have the log of 3 to the x, although we could do that. Okay? But we're going to have ones where you're going to have logarithms, so you have to solve them. You're going to have exponentials, you're going to have to solve them. We're going to do all of these methods. We're going to do the loop, which we've done. Looping is taking one and rewriting it as the other, taking a logarithm, writing it as an exponential, and solving it that way. Same basis where you get the basis the same. We've done that. We're going to step it up a notch today. And then we're going to do reciprocal powers and logs of both sides. You will absolutely need a calculator for the last couple of parts today. You cannot do them without a calculator. Okay? You will absolutely need a calculator for some of the stuff we're doing today. You cannot solve them without it. No ifs, ands, or buts. I can't do it. You can't do it. I'm a lot smarter than you are when it comes to math. Maybe not social media. Although I do have one important rule to go by on social media. Don't press send. You don't press send, you don't have to worry about having anything embarrassing out there. Right? Right? Come on, hurry up. Get your calculator. On everything. Some people. All right. So, solve using the loop method. We've done this. Looping is taking it and rewriting it in exponential form. Now, first one, log of 4x equals 2. When I have the log with no number on it, that's the common logarithm. What's our base? 10, base 10. So this means 10 to the second power is equal to 4x. 100 equals 4x. Divide by 4, x equals 25. Piece of cake. Yes, ma'am. Because that's what the definition of the common logarithm is. A log with no base, with no number shown on the base, it's log base 10, the common logarithm. Okay. Next one, I have to combine my logarithms first before I can do the loop. So first thing I do is I bring the 2 power of 2 up. Okay. And then I say, all right, now I have addition, so that's the log base 6 of 4. X squared is equal to 2. Now I loop it. 6 squared is equal to 4x squared. $36 equals 4x squared. Divide by 4. 9 equals x squared. Square root both sides. X equals 3. Move these two down out of the way. X squared, x equals 3. Square root both sides. Next one, same thing. Combine them up into one logarithm. So this is log of x over 2 is equal to 3. Once again, common logarithm is base 10. So rewrite it as an exponent. 10 cubed is equal to x over 2. 10 to the third power is 3 zeros, 1,000. Multiplied by 2. X equals 2,000. Ooh, this one's a little trickier, but it's not too bad. Combine them up into one logarithm. Log base 8 of 6 divided by 3x is equal to 2. I like to go ahead and simplify first before I get too carried away. 6 over 3x, that's log base 8 of 2 over x is equal to 2. Yes, ma'am.
Why wouldn't it be negative?
Oh, sorry, thank you, negative 2. Sorry, I lost the negative, my bad. Loop it. So I end up getting 8 to the negative 2 power equals 2 over x. Okay. Rewrite as 8 to the negative 2, solve that. So that's, let's see, negative means it's 1 over 8. 8 squared is 64. 1 over 64 is equal to 2 over x. I have a proportion, cross multiply. 1 times x is x. 2 times 64, 128. I like the next one. You won't, but I will. Log of x minus 3 plus log of x is equal to 1. Combine them up into one logarithm first. That's the log of x minus 3 times x is equal to 1. Go ahead and loop it. X minus 3 times x equals 10 to the first, which is 10. Okay. You need to distribute. X squared minus 3x is equal to 10. I have a quadratic. What do I need to have it be? Equal to 0. Can't solve it until it's equal to 0. Subtract 10x from both sides. X squared minus 3x minus 10 is equal to 0. Two numbers multiply to give me negative 10. Add to give me negative 3. Yeah, 5 and 2, negative 5. Positive 2. X minus 5. X plus 2 is equal to 0, which means x equals 5 and x equals negative 2. Okay. Questions? We've done looping before. These are a little bit of a step up, but not a lot of a step up. Okay. Do those. Okay, let's do these so we can get going on the next thing. Okay. So this one's 1 log, so just loop it around. I get 10 cubed is equal to 4x plus 2. So that's 1,000 equals 4x plus 2. Subtract 2, 998 equals 4x. Divide by 4. X equals 499 over 2, or 249 and a half. And I would allow a decimal on this one because it's just stupid to make it an improper fraction. Okay. Next one, bring the power up first and then combine them up. Log base 8 of 4x squared is equal to 2. 8 squared is equal to 4x squared. So 64 equals 4x squared, divide by 4, and then 16 is equal to x squared, so x equals 4. Next one's actually a little easier. Combine them up. Log of x over 7 equals 9. So I get 10 to the 9th power equals x over 7. So that means multiply both sides by 7. I get a 7 followed by 9 zeros is equal to x. Or you could write it in scientific notation, 7 times 10 to the 9th. Either way, I'd live with. Combine them up into one log first. Log base 4 of 2x over 5 is equal to 3. Loop it around, 4 cubed is equal to 2x over 5. Multiply both sides by 5. Oh, hang on. And you were doing so well. Let's see if it works a little better this time. So 4 cubed is equal to 2x over 5. 4 cubed is 64. So I got 64 is equal to 2/5 x. To get rid of the 2/5, multiply by 5/2. Those cancel. I get x equals 2 goes into 64 32 times. 5 times 32 is 160. So x equals 160. Okay. Last one, combine them up into one logarithm first. This is the log of x times x minus 9 is equal to 1. Loop it, that's log base 10. So I have x times x minus 9 equals 10. X squared minus 9x equals 10. Subtract 10. X squared minus 9x equals x squared minus 9x minus 10 is equal to 0. Two numbers multiply, give me 10. Subtract to give me 9. 10 and 1. It's easy. It's only one number difference between the two. So I get x minus 10, x plus 1 equal to 0, x equals 10, x equals negative 1. Questions? We've done it before. Not that much of a step difference from what we did last time. Now, this we've done as well. We've done same base. It's been a while. And these are a little bit goofier than the ones we did before. They're a little more complicated. The same base ones before were fairly simple. First one, just like we did before. Rewrite 32 as 2 to some power. So I have 2 to the x is equal to 2 to the 5th, right? 2, 4, 8, 16, 32, 2 to the 5th. So x equals 5. We did that. That's easy. That's a little bit harder on the next one. Okay? So I need to do the same concept. My base, 3 and 27, I can rewrite 27 as 3 cubed. So I have 3 to the x is equal to 3 cubed to the x plus 2 power. 27 is 3 cubed. I don't have 3 to some power equaling 3 to some power. I have 3 to some power equaling 3 to some power times a raised to another power. But when you raise a power to a power, you multiply the exponents. This is 3 to the x equals 3 to the 3x plus 6. When I raise a power to a power, I multiply the exponents. 3 times x plus 2 is 3x plus 6. Now I have the same base. Now I can go, ooh, x equals 3x plus 6. Okay. Subtract 3x from both sides. Negative 2x equals 6. X equals negative 3. A little more complicated. I have to get the same base first, but then I have to remember my rules of exponents. Oh, Power to a power, I multiply the exponents. Because I need to have a number to a power equal to a number to a power, not a number to a power to a power. Okay? Same thing here, 36 and 6. Can I write them as the same base? 36 is 6 squared. So, okay, that means I have 6 squared to the x power, because 36 is 6 squared, equals 6 to the x minus 1. Once again, I don't exactly have 6 to some power equals 6 to some power. I need to multiply the exponents. 2 times x, 6 to the 2x, is equal to 6 to the x minus 1. 2x equals x minus 1. Subtract x from both sides. X equals negative 1. So it's not exactly the same thing we were doing, but it's close. Very close. Okay, this one. This one's a little hairy. Can I write 16 as 8 to some power? 8 squared, 64, not 16. So I can't write 16 as 8 to some power. Is there a number that I can write 8 and 16 to some power as? 2. I can rewrite 16 as 2 to the 4th. So I have 2 to the 4th to the x plus 2 power equals, and 8 is 2 cubed. 2 cubed to the 2x minus 1 power. Now they're both base 2. I still have to simplify the exponents first. 4 times x plus 2, that's 2 to the 4x plus 8. 3 times 2x minus 1 is 6x minus 3. Now I have 2 to some power equals 2 to some power. My two powers are equal. 4x plus 8 equals 6x minus 3. Subtract 4x. 8 equals 2x minus 3. Add 3, 11 equals 2x. X equals 11 halves. It's a tough one because I can't write them naturally as the same base, but I can eventually get there. So the next one. 1 over 49 equals 7 to the x minus 5. Can I write 149 as 7 to some power? Yeah. 49 is 7 squared. 1 over 49 is 7 to the negative 2. 7 to the negative 2 equals 7 to the x minus 5. Negative 2 equals x minus 5. Add 5 to both sides. X equals 3. The next one's a little tricky. My first question to you is, can I write them both as powers of 25? I want to work with a smaller number. So, can I take 25 times itself and get 625? There's an easy way to check. Take 25 and square it on your calculator, see what you get. $25 squared is 625. It works. If you're not sure, try it. I can write them both as powers of 5. Let's see. And I can rewrite them both as powers of 5 so I'll get the same answer. But I don't want to work that hard. I've got a calculator to see if 625 relates to 25, and it does. So I can write them both as powers of 25. 1 over 25 is 25 to the negative 1 power. So this is 25 to the negative 1 to the x is equal to 25 squared. So 25 to the negative x is equal to 25 squared. Negative x equals 2, so x equals negative 2. If you're not sure, and I could have done it both with powers of 5, and I would have still got the same answer in the end. I still would have gotten x equals negative 2 in the end. Your turn. Okay, let's do these. So the first one's pretty easy. 9 is 3 squared. So I have 3 squared to the x is equal to 3 to the x plus 4. Multiplying 3 to the 2x equals 3 to the x plus 4. 2x equals x plus 4. Subtract 2. Subtract x equals 4. Next one's a little harder, but the 1/3 gives me a clue. I can write 81 as 3 to the 4th power. So 1/3 is 3 to the negative 1 to the 2x equals 3 to the 4th to the x minus 2 power. Rewrite them both as base 3. So that means I have 3 to the negative 2x equals 3 to the 4x minus 8. Negative 2x equals 4x minus 8. Subtract 4x. Negative 6x equals negative 8. Divide by 6. X equals 4/3, because you always reduce. Right? Right. Next one, 16. That's 2 to the 4th. 2 to the 5x minus 6 equals 2 to the 4th. 5x minus 6 equals 4. Add 6. 5x equals 10. X equals 2. That was easy. Oh, man. That was easy. $125 and 25. 125 is not 25 to some power, but it is 5 cubed. So I have 5 cubed to the x power equals 5 squared to the x plus 3 power. 3x, 5 to the 3x equals 5 to the 2x plus 6. 3x equals 2x plus 6. Subtract 2x, x equals 6. 1/36 is 6 to the negative 2. 6 to the negative 2 equals 6 to the x plus 9. Negative 2 equals x plus 9. Subtract 9, negative 11 is equal to x. That's nice. Get that out of the way. 64. Can I write 64 as 8 to some power? It's 8, what? 8 squared. Please. Oh. I know it's late in the afternoon, but come on. X plus 2 equals 8 to the 4x minus 2. So I have 8 to the 2x plus 4 equals 8 to the 4x minus 2. Or x minus 2. 2x plus 4 equals 4x minus 2. Subtract 2x. 4 equals 2x minus 2. Add 2. 6 equals 2x. X equals 3. Questions? Not too bad. We've done this. It's a step up, though, from what we did before. Okay, here's a new one. It's actually not that hard, though. But this does go back to Chapter 6. If you don't remember what Chapter 6 is all about, it's all about exponents. Solving using reciprocal powers. I want to get x to the first power. In order to get x to the first power, I need to get rid of the power that's there. I need to make that a power of 1, which means I multiply that power by its reciprocal to get 1, which means what I'm doing is I'm raising both sides to that power. What times 2/3 is 1? 3/2. 3/2. It means I'm raising them both to the 3/2 power, because I raise a power to a power I multiply. 3/2 times 2/3 is 1. X equals 4 to the 3/2. And then simplify. The 2 in the denominator means the square root. Square root of 4 is 2. The 3 in the numerator means cube it. 2 cubed is 8, so x equals 8. What times 1/2 gives me 1? What do I multiply 1/2 by to get 1? 2. 2 times 1/2 is 1. So what do I do is I square both sides. 1/2 times 2 is 1, so I get x. Negative 5 squared is 25. Okay, next one's not quite the same. It's close. But I need to have x to the 3/2 power by itself first, which means I need to divide both sides by 3. That gives me x to the 3/2 equals 81 divided by 3 is 27. I need to do that first. What times 3/2 gives me what? 2/3. So I raise them both to the 2/3 power. I get x equals 27 to the 2/3. The 3 in the denominator means cube root. Cube root of 27 is 3. 2 in the numerator means I square it. 3 squared is 9. X equals 9. The next one, I have x to the negative 1/2. What power do I bring it to give me a positive 1? Negative 2. So I bring them both to the negative 2 power. So that gives me x, negative 2 power. 2 means I square it, so it's 81. The negative means I have the reciprocal 1 over 81. What's my first step on the next one? Divide by 5. Divide both sides by 5. And I get x to the negative 2/3 is equal to 4. To get 1, I raise it to the negative 3/2. Negative 3/2. Negative 3/2. X equals 4 to the negative 3/2. So x equals 1 over 4 to the 3/2. Square 2 in the denominator means I take square root. 1 over 2 cubed, which is 1 over 8. First step on the next one, divide both sides by 2. X to the negative 1/5, my bad, negative 1/5 is equal to 2. What times negative 1/5 gives me positive 1? Negative 5, raise them both to the negative 5 power. X equals 2 to the negative 5 is 1 over negative 32. 2, 4, 8, 16, 32. 1 over 32. It's not a difficult task. If you remember the rules of fractional exponents from chapter 6, this is really easy. The idea is you get x to some power and then make that power of x 1. Okay, that's what reciprocal powers is all about. Your turn. Okay, let's do these so we can get to the last part, which is probably the most difficult. Okay, I have x to the 2/5. I need to raise it to the 5/2. So I get x equals 16 to the 5/2 power. Square root of 16 is 4. 4 to the 5th power. Somebody got that for me? I got 256 is the 4th power, right? What's after that? Somebody got it for me? Nobody did this on their calculators. You have calculators. 1024? Thank you. Thank you. Okay. Next one, I need to get rid of the -1/4. So I raise them both to the -4 power. So I get x equals 3 to the -4. X equals 1 over 81. Next one, I divide both sides by 8. X equals 1/5. Sorry, x to the 1/5 equals -3. Raise them both to the 5th power. X equals -243. Next one, raise them both to the 3/2 power. X equals 4/9 to the 3/2. 2 in the denominator means square root, so I get x to the 2/3 cubed, which means x equals 8/27. Next one, what do I have to do first? Divide both sides by 7. I get x to the 1/2 equals 7. And then to get rid of the 1/2, I square both sides. X equals 49. Not too bad. Next one, same thing. I have to divide both sides by 4. And I get x to the -1/3 is equal to 3. Raise them both to the -3 power. X equals 1 over 27. Okay. Yes. Not too bad. Each one's a different type of problem. Each one's a different thing you have to do to solve. But it's not too bad. Okay. Now, when we did problems like this before, we wrote them as a same base problem. I can't write 13 as 4 to some power. It doesn't work. So here's what you have to do. You have to take the log of both sides. If you can't get the same base, you take the log of both sides. So that means I have the log of 4 to the x equals the log of 13. Notice I'm using the common logarithm. This is because this is what your calculator will do. You cannot solve these problems without a calculator. Now, I still have x as my exponent, right? But my rules of logarithms let me bring that down out front. That means I have x times the log of 4 equals the log of 13. Okay. X log 4 is the same thing as 2x, or 3x, or -5x. It's a number times x. The log of 3 is a numerical value. It's not a variable. It's not some goofy function or something. It is a numerical value. It's like when you did the sine at 45 degrees. It was a number, right? Same thing. Log of 4 is a number. If I want to get x times a number and I want to get x by itself, I divide by that number. So I divide both sides by the log of 4. I get x equals the log of 13 divided by the log of 4. This is not the log of 13 fourths. This is the log of 13 divided by the log of 4. When you do this on your calculator, and you have to do this on your calculator, You do not take the log. You have to be careful how you put it in. You either use parentheses or you do it one step at a time. Do parentheses, log of 13, end the parentheses, divide. Begin parentheses, log of 4, end parentheses. Or do the log of 13, then divide that by the log of 4. You have to be careful. If you type in, hit log 13, log 4, it'll take 13 divided by the log of 4 and then take the log of that number, which will be wrong. You have to be careful how you type it in. I generally take the log of the numerator, log of 13, divide that by the log of the denominator, log of 4. And you get 1.850. I want 3 decimal places, truncated or rounded. Do that. Make sure you get that number on your calculator. You have to know how to do this. You cannot solve these problems without taking logarithms on your calculator. You can't. It's impossible. It's like sucking a Cadillac through a straw. You just can't do it. Let's do the next one. Did everybody get the same answer? You absolutely need to make sure you're getting the correct answer on this one. You have to do this right. If you're not getting the correct answer, we need to make sure why you're not getting that number. It's probably user entry error. And make sure you're getting the right answer. Next one, same thing. Take the log of both sides. You get the log of 3 to the x equals the log of 1.9. Bring the power down out in front. X log 3 is equal to the log of 1.9. Divide both sides by the log of 3. X equals the log of 1.9 divided by the log of 3. And once again, your calculator is your friend. Log 1.9 divided by log 3. 0.584. Which is not 1.9 divided by 3. Okay. Close, but it's not. Okay. Next one, same thing. First step, log both sides. Log of 5 to the x plus 1 is equal to the log of 263. Bring the power down out in front. X plus 1 times the log of 5 is equal to the log of 263. Divide both sides by the log of 5. X plus 1 is equal to the log of 263 divided by the log of 5. Subtract 1 from both sides. Notice I kept the x plus 1 because that was my whole exponent together. Subtract 1, x equals the log of 263 divided by the log of 5 minus 1. And then I plug it into my calculator. I don't plug it into my calculator until my final step. Do not take the logarithms until you're ready to finish it out. Keep them written as logarithms till the very end. Log of 263, 2.41. Divided by log 5. 2.462 minus 1. 2.462. What do you think I need to do on the next step? What do I need to do first? Subtract 6 from both sides. I have to get that the power part by itself before I can do that. So I subtract 6. 3 to the x is equal to 72. Now I take the log of both sides. Log of 3 to the x is equal to the log of 72. X log 3 is equal to the log of 72. Divide both sides by the log of 3. X equals the log of 72 divided by the log of 3, which is, well, I don't know, some number about 4 or 5, I guess. No, less than that. 3.893. 3.893. What do you think I need to do on the next one? Divide by 2 first. Let's divide both sides by 2. I get 5x equals, we're all dealing with decimals anyways. Take 477 divided by your calculator, divided by 2 on your calculator to get 238.5. Might as well. 238.5. Normally I love fractions. I hate decimals, but we're doing decimals anyways when we finally get to the logs. Do your decimals now. Doesn't matter. Log both sides. Log of 5 to the x equals the log of 238.5. Bring down the x. X log 5 is equal to the log of 238.5. Divide by log of 5. X equals the log of 238.5 divided by the log of 5. Uh, 3.401. You with me? This is what logarithms are really good for. Okay, there's, like I said, there's 2 things they're good for. One is the statistics thing, which is great, fantastic. It's wonderful. If you need it for that, you can't beat it. But this is what we use logarithms for almost for everything else. You cannot solve for an exponent without logarithms. Unless I can get the same base, this is it. This is the only way to do it. Okay? You can't do it any other way other than logarithms. So that's why they're so useful. Okay? You want to solve for the exponent, this is it. This one, I don't need to do anything first. Just take the log of both sides. Log of 7 to the 2x equals 130. I'm sorry, log of 130, log of 130. 2x log of 7 equals the log of 130. Now, here's a fun one. I have x being multiplied by what? What is x being multiplied by? 2 and the log of 7, right? Because it's 2 times x times the log of 7. I want to get x by itself, divide by 2 log 7. No reason I can't do it all in one step. Everything cancels out except for x. Log of 130 over 2 log 7. Yeah, you get your calculator out. $1.251. That's what I get. You guys are so lucky. You have these to use for this. When I was your age, and I wanted to find the logarithm of a number, you know what I had to do? I had to take a book, my textbook, and I had to go to the back of the book and I had to look it up in the table of values. Oh, not cool at all. So happy I don't have to teach you guys how to do that. We'll do these last two before I set you on your own to finish it up. Okay. Log both sides. Log of 5 equals log of 95 to the x. Bring the x down front. Divide by the log of 95. X equals log of 5 divided by the log of 95. And I get 0.353. Same thing on the next one. Take the log of both sides. Bring the power down in front. 2x minus 3 times the log of 4 is equal to the log of 263. Okay, see if this one gets a little goofy. I need to divide both sides by the log of 4. So I get 2x minus 3 is equal to the log of 263 divided by the log of 4. Add 3 to both sides. Like I said, it gets really goofy in a hurry. Add 3 to both sides. 2x is equal to the log of 263 divided by the log of 4 plus 3. And then divide both sides by 2. So x equals the log of 263 divided by the log of 4 plus 3, all divided by 2. Yeah, I know, it's a pain in the butt. That's why you have this thing. Just do it step by step. Figure out the fraction. Add 3 to that. Take that number, divide it by 2. Log of 263. Divide that by the log of 4. Add 3. Divide by 2. 3.510. Rounding it off. 3.510. It's a pain in the butt. It's a little goofy. And I like to hold on to my logarithms till the very end before I plug them into my calculator. But I like to have my answer as exact as possible. If I round off too early, my answer may be wrong by a round-off error. If I take the log of 263, get that decimal, write it out to 3 decimal places, do the same thing with the log of 4, then divide it out, I might be off in my answer. Okay. Okay, do those. Yes, today is a long day. Here we go. Let's do this. So first one, take the log of both sides. Bring down the x, so I have x log of 8 equals the log of 22. Divide both sides by log 8. X equals the log of 22 divided by the log of 8. So calculator, log 22 divided by log 8 equals 1.486. Next one's the same thing. Okay. Take the log of both sides, and I end up with, bring the x down in front, x log 6 equals the log of 89.4. Divide both sides by log 6, x equals the log of 89.4 divided by the log of 6. So x equals 2.508. 2.508, rounding it off. Last one, same thing. Take the log of both sides. Log, bring the x plus 1 down, x plus 1. Log of 8 equals the log of 127. Divide both sides by the log of 8. X plus 1 equals the log of 127 divided by the log of 8. Subtract 1. X equals the log of 127 divided by the log of 8 minus 1. Log of 127 divided by log 8 minus 1. Yes. Yes. Equals 1.330, rounding it off. Question on those top three? They're fairly straightforward, they're not too bad. Okay. What's my first step on the next one? Subtract 5 from both sides. 3 to the x is equal to 109. Take the log of both sides. Log of 3 to the x equals the log of 109. X log 3 equals the log 109. X equals the log of 109 divided by the log of 3. .270. Next one, I need to divide both sides by 3 first. So 4 to the x is equal to 78. Yes. Doing that in my head. Proud of myself. Take the log of both sides. Bring the x down. X log 4 equals the log of 78. Divide both sides by log 4. X equals the log of 78 divided by the log of 4. And 3.143. 3.143. Next one, log of both sides. So I get log, bring down the 2x, log of 9 is equal to the log of 159. Divide both sides by 2, log 9, 2 log 9. X equals log of 159 divided by 2 log 9, log of 159. Execute, divide by 2, execute, divide by log of 9. Execute. 1.535. And if you're close to that on the number, you know, that last decimal one, if you're close. Next one, log both sides. Log. Bring the power down in front, x minus 2. Log of 16 equals the log of 49. Divide both sides of the log of 16. X minus 2 equals the log of 49 divided by the log of 16. Add 2x equals the log of 49 divided by the log of 16 plus 2x equals 3.403 or 3.404. And then the next one's a pain in the butt. Take the log of both sides. Log 2x minus 3 log 9 equals the log of 384. Divide both sides by the log of 9. 2x minus 3 equals the log of 384 divided by the log of 9. Add 3 to both sides. 2x equals the log of 384 over the log of 9 plus 3. Divide both sides by 2. X equals the log of 384 divided by the log of 9 plus 3, all divided by 2. Gotta loosen up my fingers here. Log 384 x cubed divided by log 9 x cubed plus 3 x cubed divided by 2 x cubed. 2.854. 2.854. And if you got that, give yourself a pat on the back. You figured it out?
Oh, no,
Oh.
yeah.
Okay. Good, because I don't want to do that again. Okay, now, word problems. Yay! Okay, so once again, I want to remind you of the equation we use for finding these ones. The amount after a particular time is the original amount times 1 plus the rate written as a decimal raised to time t. We did this the first day of this chapter. We found big A. Now we're finding how long the time is. We're solving for the exponents. Same idea, plug the numbers in. This is my original amount. This is how much I'm ending with. This is my interest rate. T is what I'm looking for. Plug the numbers I know into the equation, solve for what I don't. 1,500 equals 1,000 times 1 plus 0.031 to the t power. We've got to solve for the exponent. So, step by step, don't rush through this. First thing you do, divide both sides by 1,000. So you get 1.5 equals 1.031 to the t power. Add what's in the parentheses, divide by 1,000. Does that make sense? You see what I did there? Okay. Now I do exactly what we just got done doing. Take the log of both sides. The log of 1.5 equals the log of 1.031 to the t power. Bring the t down out in front. Log of 1.5, t log of 1.031, divide by log of 1.031. T equals the log of 1.5 divided by the log of 1.031. That's going to be long. Just say log 1.5 divided by log 1. 13.28 years. So about 13 years, 4 months. Between 3 and 4 months. To get $500. So question B Same thing. Only our interest rate has improved because we shopped around to get a better interest rate. Same setup. 1,500 equals same thing. So we're using the same deposit, right? $1,000. What's my new interest rate? 5%, which would be 0.05 to the T. Divide by 1,000, combine that addition there. 1.5 equals 1.05 to the T. Log both sides. Bring the T down out in front. Divide by log of 1.05. T equals the log of 1.5 divided by the log of 1.05. T equals less time. Ooh, 8.31 years. Now, that's to get $500 more on an $1,000 investment. That's to get half of your investment back. If you invested $100,000, it would take you the same amount of time to get $50,000. Does that make sense? It takes that long to get half back, no matter what your initial investment is. Okay, to have 1.5 times what you invested, it'll take that long. It doesn't matter what the initial amount is, it'll take you that long to get 1.5 times it. So when you're doing doubling, it doesn't matter how much you put in, how long it takes to double. It takes the same amount of time to double $100 as it does to double $100,000. Okay? Which leads me to your problems. Okay? Do those two together.
Yay.
No, seriously. I got a doctor's appointment. That bell rings. You guys are out the door, and I'm locking it behind you. I'm on my way out the door, too. I got a doctor's appointment today. So, 2,500 equals, or actually, no, 2,500 is what I start with. How much do I want? I want 5,000 equals 2,500, 1 plus 0.05 to the T. Divide both sides by 2,500. 2 equals 1.05 to the T. Take the log of both sides. Log of 2 equals the log of 1.05 T. T log of 1.05 is equal to the log of 2. T equals the log of 2 over the log of 1.5. There used to be a rule for this, for doubling. Log 2 divided by log 1.05. 14.2 years. Then on the last one, okay, the last one, we'll set it up. Okay. Population of the country is currently 8,100,000. Studies show this country's population is increasing at 2% a year. How long to reach 9 million? Here's the deal. Don't write 9 million. Write 9. And know that I'm working in millions. 9 million equals 8.1 million. 1.02 to the T power. That's what you do. I don't want to have a buttload of zeros, because when I divide by a buttload of zeros, they're all going to go away anyways, right? Okay. 9 divided by 8.1. .111111, or I should say 1.11111 equals 1.02 to the T. Take the log of both sides. Bring the T down. T log of 1.02 equals the log of 1.111111. Don't round it off. Leave lots of decimal places. Go more than you need to go while you're working the problem, so you don't have a round off error by rounding off too soon. Divide by log of 1.2. T equals the log of 1.111111 over the log of 1.02 equals, and we're doing this in record time, log of my answer divided by log 1.02. It'll take it 5.32 years.